Hello, and today's purpose of the day is I can use scientific notation. Please be prepared to complete the warm-up later in class. Feel free to read ahead if you would like. Continuing with the warm-up, please be able to read the following sentences with your table partner. Feel free to read ahead if you would like. Scientific notation is a number written in the form of a times 10 to the power of n, where a is strictly between 1 and 10. 1 can be, and if you notice this inequality sign here, 1 can be equal, a can be equal to 1 or greater than 1, but must be less than 10. A cannot be 10, so that's why the signs there are as they are. And n can be any integer value. So, for example, we could have 1 times 10 to the third power, but we cannot have 10 times 10 to the second. Cannot have 10 as our A or our first number written in scientific notation. So just to recap, going from standard form to scientific notation, the first step will be to move the decimal point until it is to the right of the first non-zero digit. The result is a real number, A. Step 2, move the number of places n and the direction that you move the decimal point. Step 3, if the decimal point is moved left, we write the number as a times 10 to the nth power, and if the decimal point is moved to the right, we write the number as a times 10 to the negative n, so a negative exponent. And lastly, we will remove the extra zeros. So let's look at expressing each number here in scientific notation. So I have 201 million. So I'm going to write this as 2.01 times 10 to the, now I'm going to count how many zeros are after 2.01 because that's the first integer that's between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 2.01 times 10 to the 8th. Now if we look at number 2, the first integer between 1 and 10 here would be 5.41. And then now I have to count how many zeros are to the left of that 5, so, or how many decimal place values. So 1, 2, 3, 4, 5. So it's 5.41 times 10 to the negative 5th. Okay, and if we look at going from scientific notation to standard form, step 1 is note whether n is greater than or less than 0. Step 2, if n is greater than 0, we'll move the decimal point n places to the right, or if n is less than 0, we will move the decimal point negative n places left. Step 3, insert zeros, decimal point, and commas as needed for place value. So we'll express each number here in standard form. So 6.32 times 10 to the 9th, so I'm just going to write out 632, and now 9 places after the 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill each place value with a 0, and then figure out what my number is. So I have 6,320,000,000, and then I fill the rest with zeros. Now if I look at number 2, 4 times 10 to the negative 7th, I'm going to write down 4, and then my decimal comes after 4, and then I'm going to move 7 places to the left. 1, 2, 3, 4, 5, 6, 7, and again I move to the left because of that negative 7. And then always when I make a decimal, it's good to put a 0 in front so your reader knows, hey, it's decimal place and then zeros following it. So there are 1, 2, 3, 4, 5, 6 zeros in front of the 4. And a good little hint and rule to follow is that whenever you have, one digit here and you're moving to the left with a negative exponent, you're always going to have one less zero than your exponent. So this was 7 places to the left, so I had 6 zeros in front of my 4 for my final answer. So just a good little tip to follow. Now let's do a little practice of multiplying with scientific notation. So I'm going to look at number 1, and I'm going to break this down because this will be so much easier if I break it down and look at this in 2 different parts. So I have 6.5 times 7, and then I have my 10 to the third, negative third, and 10 to the 5th. Now if you recall from monomials, when we multiply exponents with the same base, we really add the exponents. And here we have the same base with our exponents, 10 and 10. So I'm going to multiply 6.5 times 7, and I get 45.5. and then 10 to the negative second and 10 to the fifth, or excuse me, 10 to the negative third and 10 to the fifth. Negative 3 plus 5 is really 10 to the second, so that's 2. So my answer is 45.5 times 10 to the second. However, this number here, 45.5, is not between 1 and 10. I need to change that number so it's between 1 and 10. So I'm going to move my decimal one place to the left. And when I do that, with the exponent, I have to make sure. I wanted to go to the right 2 places, right? Because that's 10 to the second. But if I move it back to the left 1 place, now I have to go an extra unit to the right. So what this will turn into is 4.55 times 10 to the third, and that's in scientific notation, and let's also practice writing this in standard form. So that would be 4,550. Okay, let's take a look at the second example. And again, I want to break this up into 2 parts, so 6.2 and 1.95, and then I'll look at the 10 to the 12th and 10 to the negative 15th. So I'm breaking this up, so 6.2 times 1.95 gives me 12.09, and then 10 to the 12th, and then plus negative 15 gives me 10 to the negative third. But now I'm breaking a rule. This number has to be between 1 and 10. So if I move my decimal 1 place to the left and get 1.209, I wanted to go 3 units to the left, but now I already went 1 extra to the left. So I have to go 1 less than 3, which would be 2, and I still have to go to the left, so it's actually 10 to the negative second. And if I write this in standard form, so 1.209, 1 2 place values to the left, gives me 0.01209 in standard form. So that would be my answer there for number 2. Now let's take a look at a few examples of dividing with scientific notation. So I'm again going to break this up into 2 parts, my coefficients and then my exponents with the same base. And I'm going to divide the coefficients, so 3.066 divided by 7.3, and I get 0.42 times 10, and then this is exponents with the same base, and when we divide, we really subtract, if you recall from working with monomials, and 10 minus 5 is, or excuse me, 3 is 5, but I am breaking a rule because I cannot have my number here be between or less than 1, or needs to be between 1 and 10. So I'm going to move this decimal over 1 place, and I get 4.2. I wanted to go 5 to the right, but I already moved 1 spot to the right, so it's going to be times 10 to the 4th. And then written out into standard form would be 42,000. Okay, and looking at the second example of dividing, let's break this up again, and I'm going to say 2.3958 divided by 1.98. And I get 1.21, so that's nice, that's between 1 and 10. And then 3 minus 8 is actually negative 5. And then writing this out in standard form, if I have 1.21, 5 places to the left, 2, 3, 4, 5 will give me 4 zeros in front. So 0.1234,121. And that would be my final answer then for the second example. Now let's take a look at one word problem. In the U.S., a CD reaches gold status once 500,000 copies are sold. So I'm going to highlight that. A CD reaches platinum status once 1 million or more copies are sold. So I'm going to highlight that as well. Part A says, express the number of copies of CDs that need to be sold to reach each status in standard notation. Well, for gold, it's just 500,000. And then for platinum, it's 1 million, so that would be 6 zeros. So again, just practicing writing out some numbers in standard notation. B, write each number in scientific notation. So this would be for gold status, 5 times 10 to the 5th. And then for platinum, this would be 1 times 10 to the 6, because again, we have 6 zeros following. And part C says, how many copies of a CD have sold if it has gone platinum 13 times? Write your answer in scientific notation in standard form. Well, to go platinum, you need 1 million CDs. So in standard form, that would be 13 million, right? 1 million times 13. And then in scientific notation, it would be 1.3 times 10 to the 7th. That would be my final answer. All right, now we'll look at our final word problem example. Suppose a satellite radio company earned 125.4 million in 1 year. Write this number in standard form. So I'm going to say, so I have 125,400,000. So that would be standard form, but in scientific notation, remember our first number has to be between 1 and 10. So this would be 1.254 times 10 to the, now we have to look at how many zeros we had. Let me fix that multiplication sign. So here it'd be 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th. Question C says, if the following year the company earned 2.5 times the amount earned the previous year, determine the amount earned. Write your answer in scientific notation in standard form. Well, we want to take 125.4 million and multiply it by 2.5. And we get 313.5 million. So now if we want to write that into standard form, that's going to be 313,500,000, and then into scientific notation, 3.135 times 10 to the, and again, we'll probably have the same exponent as above, but let's just double check. 1, 2, 3, 4, 5, 6, 7, 8. So 3.135 times 10 to the 8th, and that would be my answer in scientific notation and standard form. Thanks for listening. Have a great day. Bye-bye.